Hi everyone. In this lesson we're going to be looking at how to find the trig values of special angles. Okay? How do we find the trig values of special angles? So in order to do a problem like this, where it says find the following trigonometric values for cosine of 240 and sine of 240, we first have to understand what these special angles are and where they come from and how we can apply them. So let me take 5 minutes and kind of review what you might have learned in geometry. Okay, so first thing, these are there are two special right triangles. Okay, I'm going to show you what they are. That's an O, by the way. Okay, and the first one we have is the 45, 45, 90 right triangle, and then we're going to have what's called the 30, 60, 90 right triangle. Okay, so what is the 45, 45, 90 right triangle? Well, it looks like this, right? I'll try to do my best to draw a. Okay. Okay. So here is a right triangle, and we're going to say that in this right triangle, we have two acute angles that are both 45 degrees, like that. Okay, so that's why we call this the 45, 45, 90 right triangle, because there's two 45-degree angles and then the right angle, which is 90. Now, in this triangle, the side ratios go like this, all right? And there could be many of these ratios, but one of them, the most basic one, is this: 1, 1, square root of 2. Okay, so this is an example of a 45, 45, 90 right triangle, because remember, if you were to use the Pythagorean identity here, it would be x squared, right? A squared plus b squared equals c squared, correct? So if you were to do a squared plus b squared equals c squared, and you were to take these two legs and square them, correct? You would have 1 squared plus 1 squared is equal to radical 2 squared, correct? And if you were to square the ones, it would be 1 plus 1, which is 2, and the radical 2 squared is 2, correct? So it works out. All right? Now, you know what, let me erase this for now. I'm going to erase this for now, and I'll come back to it in a minute. Now, so what I'm going to do is now I'm going to take our trig ratios. I'm going to take the sine of 45 degrees and see what that comes out to. What is the sine of 45 degrees? Well, by definition, sine is opposite over hypotenuse, correct? It's sine is opposite over hypotenuse. So let me write the rest. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, right? So I'm going to take the sine first. It's opposite over hypotenuse. So from the 45-degree angle, I'm going to go sine of 45 degrees is opposite over the hypotenuse. So it's 1 over square root of 2. Okay? And what's the cosine? Well, the cosine of 45 degrees is adjacent. It's adjacent over hypotenuse, correct? So 45 degrees, and you can go from here, you can work from this angle or this angle, they're both the same. So cosine is adjacent over hypotenuse, so it's adjacent, which is 1, over hypotenuse, which is, again, radical 2. Okay, and now let's take tangent. Tangent of 45 degrees is equal to, tangent is opposite over adjacent, right? So opposite is 1, adjacent is 1, they're both 1, so it's 1 over 1, which gives us an answer of 1, correct? So, so this one is easy. Tangent of 45 is 1. Now let's go back here. Mathematically, we don't like to have radicals in the denominator. Okay, we want to have rational numbers in the denominator. So what we can do is we can rationalize, make the denominator a rational number. Radical 2 is an irrational number, correct? It's a number that doesn't end, that doesn't repeat, and it doesn't end. So how do I change the denominator into a rational number? I can multiply top and bottom by radical 2. And what I get now is 1 times radical 2 is radical 2. And radical 2 times radical 2 is radical 4, which is just 2, correct? So this is square root of 4. Radical 2 times radical 2 is radical 4. Square root of 4, and the square root of 4 is 2. Okay? So the sine of 45 degrees is square root of 2 over 2. And likewise, the same thing with cosine of 45. Again, when we multiply the top and the bottom by radical 2, we get radical 2 over 2. So these are our first 3 values, okay, for sine of 45, cosine of 45, and tangent of 45. Okay? Now, we're going to look at the other special right triangle here. Okay? I'm going to clear this board. And now let's take a look at our next special right triangle, which of course is the 30, 60, 90 right triangle. And the 30, 60, 90 right triangle kind of looks like this. All right. Again, it's a 90-degree right triangle. And this larger angle here is the 60-degree. The smaller angle here is the 30-degree. Okay? And again, there could be many different combinations for the sides of a 30, 60, 90 right triangle, but one of them is this. The side opposite 30, if I call that 1, and the side opposite the side opposite the 60, I call that radical 3. Then the hypotenuse is going to be 2. All right, and you're going to see why this is true. Again, I'm going to apply the Pythagorean theorem. So again, a squared plus b squared equals c squared. Okay, and again, there could be different combinations for those sides, but this is one. This is probably the basic one. And now let's take a look. So if I take the 2 legs and I square them and I add them, so it's going to be 1 squared plus radical 3 squared, then they should equal, this should equal the hypotenuse squared, which is 2 squared. Okay, let's see if it works. So 1 squared is 1, plus radical 3 squared is 3, right? Because the square root and the square are inverse functions, so they're going to cancel each other out. Just going to get 3. And what is 2 squared? That's 4, right? So 1 plus 3 is 4, and that is equal to 4. That is correct. So these 3 sides, they work. They satisfy the Pythagorean theorem. All right? Now using these 3 side lengths, I'm going to again do my sine, cosine, and tangent. And again, it's so, ka, toa. All right? So let's do the sine. Sine of, now I'm going to do 30 first because it's smaller. So the sine of 30 degrees. Okay? What is the sine of 30 degrees? Now we're working from this angle up here, right? We have to now work from this angle because these are not the same angles here. So we're looking for the 30 first. So if we're looking from the 30 first, okay, sine by definition is opposite over hypotenuse. So it's opposite, which is 1, hypotenuse is 2, right? So it's sine of 30 is 1 over 2. Okay. Now let's do the cosine of 30. Cosine of 30 is adjacent over hypotenuse. So the side adjacent now is radical 3 and hypotenuse is 2. So cosine of 30 degrees is radical 3 over 2. And the tangent of 30 degrees, okay, the tangent is opposite over adjacent. So opposite over adjacent. So it's 1 over radical 3. But again, we don't want to have a irrational number denominator, so we multiply top and bottom by radical 3, and that comes out to radical 3 over 3. Okay? So, okay, there we go. So here are our 3 values for sine of 30, cosine of 30, and tangent of 30. And let's do the same thing now for the 60 degrees. So sine of 60 degrees. Now we're working from this angle, right? We're working from the 60-degree angle here, right there. So from the 60, all right, opposite, sine is again SOHCAHTOA, right? So sine of 60 is radical 3, opposite side, over the hypotenuse. So radical 3 over 2. Cosine of 60 degrees is adjacent over hypotenuse, which is 1 over 2. And tangent of 60 degrees is equal to opposite over adjacent. So it's radical 3 over 1, which is just radical 3. Okay, so these are the basic values for our sine, cosine, and tangent for the 30 degree and the 60 degrees, and the one we saw that for the 45 degrees. Okay, these are the most important angles that we have so far. Okay, so I'm going to stop it here for this video, but in the next video I'm going to summarize all of the values for sine, cosine, and tangent of 30 degrees, 45 degrees, and 60 degrees, okay? And we'll sort of put that, we'll organize it into a nice little table that's easy for you to memorize, okay?